We are talking about a new way to protect blast furnace hearth using synthetic titanium dioxide or TiO2. This method is used at a number of steel plants all around the world. Today, in this presentation, we are going to share few except from ROGESA of Germany. So their furnaces face intense heat, and this technique of co-injection of TiO2 helps fight against early wear and tear. So in the subsequent slide, we will come across some statistical data how they co-inject to get benefit in arresting the higher temperatures in the hearth and consequently extending the campaign. So Rogesa is a joint venture and it's basically a plant producing around 4.4 million ton of hot metal yearly. Their two furnaces, BF4 and BF5, are massive with hard dia over 11 meters. Daily output exceed around 6,000 tons and it's a big production. But they have had issue with the hearth erosion caused by high temperatures. So previously TiO2 from ilmenite was added with the solid charge, slow to react and not very efficient. Uh, but now they uses an innovative approach, that is injecting synthetic TiO2 directly through the tuyers. This heats the hearth area more directly, reducing material uses and avoiding problems with slag quality. ROGESA uses two type of RUTILIT grades. One is RUTILIT NF for regular production and RUTILIT F50 for fixing hot spots. These powder contain 45 to 60% TiO2 and have fine particles averaging 20 to 30 microns. The real advantage then, what is the real advantage? They form TiCN coating that protect the hearth lining from extreme heat. So to apply Rutilit, it's blended with a coal at a ratio of about 1 to 2 kg per ton of hot metal. This mix is dried and finally ground, then injected through all tuyers using a pulverized coal system. So this way the TiO2 reaches deep into the hearth where it needed most. So this method helps control hearth temperature, dropping it by 100 to 600 degrees centigrade while keeping hot metal temperature stable between 1465 and 1485 degrees centigrade. The slag still meets cement industry specification with less than 0.9% TiO2. That means better production with no compromise. Now coming to the hearth wear inspection. After long use, BF number 5 showed minimal wear in graphite zone but more in plain carbon area. Importantly, EDX tests reveal TiCN protective layers in critical zones. That proves the injected TiO2 actually reaches and seal the vulnerable areas. Compared to old method, this new approach is cost effective, less TiO2 is needed and cheaper than ilmenite. It also helps extend the furnace campaign life, reducing